All right, guys, here's a quick video of this practice test. At least I hope it's kind of quick. See what happens here. The first one says graph that exponential functions tell domain range and asymptote. Remember, E is really 2.71828. We talked about 2.7 the other day in class, which means it's exponential growth. The -2 at the end shifts your asymptote, shifts the whole graph down 2, so the asymptote's at -2. Remember, usually we go up 1 from there, but because it says x plus 3 in the exponent, I'm going to go up 1, left 3, opposite of what you think. And because it's growth, I'm going to go to the right one, plug in that point. Basically, it's going to give me 2.7 above the asymptote every single time. So I'm going to go above the asymptote by 2.7 to get my other point right there. Then I'm just going to connect them. There's the graph. Domain is always all reals because it's going left and right forever. The range is going to go from -1 to infinity. Notice there's a parentheses because the graph doesn't ever touch the -1. The asymptote is going to be y equals, sorry, it should be -2 right there. Both of those are -2. Sorry, I was trying to look at the graph instead of I should have looked up here. -2. Old man eyes, sorry about that. Number 2, the population of species of bird is limited to type of habitat required for nesting. The population behaves according to, that's logistic growth like we talked about the other day. I'm going to have to be honest with you right here. I did not bring my calculator home, so this is going to be interesting. It says at time 0. I can do this one though. At time 0, you're putting 0 in for the t, which makes that whole exponent become 0. E to the 0 power is 1. So I'm going to add, well, 27.5 times 1 is 27.5. If I add 0.5, that's 28. 5,600 divided by 28 would be 200. So there was 200 birds at the beginning. I actually did that without the calculator. This one's going to be impossible without it, but I'll show you what to punch in. After 3 years, which is basically putting 3 in for the t, you would say 5,600 over 0.5 plus 27.5 e to the -0.44 times 3 power. Now, when you type that in, please make sure you put the whole denominator in parentheses. And because I didn't bring my calculator home, guys, I'm sorry, I don't have the answer to that. Number 3, a radioactive substance decays in such a way that the amount of mass remaining after T days is given by this. Sorry about that. Given by this right here, where M of T is measured in kilograms. It says find the mass at time 0. So again, plug a 0 into your exponent, which makes the whole exponent 0. E to the 0 is 1. 1 times 6, 6. Okay, that number right there is always, if you're giving a decay function, that's always going to be your initial mass or initial whatever, your initial amount. It says how much decays after 20 days or remains after 20 days. So we'll do M of 20. Come on now. Come on, iPad. M of 20 equals 6 times E. And in my calculator, if I had it, I'd punch in -0.07 times 20 as my exponent, just like that. And whatever it equals was how much is left after 20 days. I'm sorry again, forgot my calculator. Okay, number 4. If $6,500 is invested at an interest rate of 7.25% per year, compounded continuously, that's the key word. Anytime you see continuously, wait a second, find the value after 12 years. Back to continuously. Anytime you see continuously, your formula is going to be the PERT formula. Okay, so when I plug that stuff in, P's principal, how much you start with, 6,500, E is E, R is rate, be careful, make sure you move that decimal back 2 spots, times 12, because 12 is the time. And you'd punch it in your calculator just like that to get your final amount. One more time. I forgot my calculator. So sorry. Number 5, evaluate the log. Remember, I'm going to try to draw this on here. I may not be very successful, but this means 3 to some power is 81. So the answer to a log is the exponent. What power would you raise 3 to get 81? 4th power. Okay, how about 8? 8 to what power is 2? Now, anytime you're going down in value, what you're really doing is you're taking a root. Remember, bottom is the root, top is the power. What root of 8 is 2? And the answer is just the cube root. Well, how do you write cube root as an exponent? You write it like this. Bottom is the root. The cube root of 8 is 2. Number 7, you shouldn't miss number 7, I'm just saying. Remember, if you see ln, the base is e. They're never going to write it there, but the base is e. So what that's asking you is, E to what power is e to the ninth? Are you kidding me? E to what power is e to the ninth? The ninth power. Number 8. Same deal. 3 to the 5th equals x. So I'll write 3 to the 5th equals x. If you punch in 3 to the 5th, you will get 243. That's x. Number 9. Same pattern. 25 to the x power equals 5. How do you get from 25 to 5? You take the square root. What exponent means square root? 1/2, because bottom is the root, top is the power. Okay, look at number 10. Number 10, x to the 1/3 equals 5. All right, just think about how to solve that. 1/3 power means cube root. That's what it really means. What's the opposite of cube root? Cubing. So what I would do, or another way to look at it is like this. Raise both sides to the reciprocal power. And over here, it just cancels. That leaves 5 cubed, which is 125. Number 11, graph this thing, graph a log. All right, when you graph a log, you got to freehand this, freehand on your test also. Remember, a log is the inverse of an exponent or an exponential function. So when we did exponent graphs the other day, the x-axis was always the asymptote. If you're doing a log graph, the y-axis is the asymptote, but it's been shifted right 2, which means my asymptote is going to be going through 2. Okay, there's the asymptote, which means I can go ahead and do this. My asymptote is x equals 2, okay, because it got shifted 2. Now, when we graphed exponentials the other day, I would always go up 1. That was like number 1 on this practice test. I went up 1 from the asymptote. Well, on a log, instead of going up 1, you go right 1. So I'm going to go to right here. There's my first point every time. You're going to need 2 points. Okay, so the second point, please listen to what I'm going to do. I'm going to make this parenthesis be the same thing as that 3. So what am I going to put in for x to make that parentheses equal 3? And the answer is 5. Because if I do 5 minus 2, that's 3. And if I put that 5 in, it's going to say this. It's going to say log base 3 of 3. And think about what that is. That means 3 to what power is 3? That's 1. So if I plug in 5, I get 1. So I'm going to go to 1, 2, 3, 4, 5, up 1. There's my second point. The graph's going to do this. And that's it. Okay, so the domain is not all reals. Okay, the domain is going from 2 to forever. But the range now is all reals. I told you a log is the inverse of an exponent. When we did exponentials last week, that was the domain, that was the range. Everything switches. Your x's and y's switch with inverses. Let's go to 12. Find a polynomial of degree 3 with those zeros. So it means you're going to write them as factors, x plus 4, x minus 4, and 5, which is x minus 5. We're going to set that equal to f of x. Okay. What I notice is these two right here are conjugates. When you do conjugates, remember, you can just do foo. So if I do x plus 4 times x minus 4, I get x squared minus 16. And I also have this x minus 5 over here. So to finish up, I'm just going to do FOIL. I'm going to go first. I'm going out of order. No, not outer, inner, and last. And guys, that's it. That's your answer. A couple more here. 13, sketch the graph of the polynomial function. Make sure your graph shows all the intercepts and exhibits the proper end behavior. Okay, so first of all, I'm looking, there are 3 x's in there, which means it's odd. Also, there's a negative in the front, so it's odd negative. So now I'm going to put my intercepts up there. It's going to cross the x-axis at -3, at +4, and -1. Also notice there's no squares or anything, so it's actually going to pass through. It's not going to bounce. Now to find the y-intercept, I'm going to put a 0 in for all the x's. 0, 0. So really I'm just going to forget the x's. Okay, and that gives me 3 times -4. That's -12 times 1 is still -12. But there's a negative sign in the front, so it makes it +12. So the y-intercept is way up here at +12. Okay, because it's odd and negative, it means it's going up to the left and down to the right. So it's going to go down through there, come up. It's going to come way up there and hit the y-intercept. Then it's going to come back down, and that's what it's going to look like. Okay, that's your x-intercepts, your y-intercepts, and your end behavior. All looks great. And the last one here, number 14. 2 cosine x minus 1 is 0. Let's solve it for cosine. Move the 1 over first. Then we're going to divide both sides by 2. And that's asking you, where is cosine 1/2? Hopefully you don't even need your unit circle anymore. But cosine is 1/2 at pi over 3, which is quadrant 1 because it's positive. Where else is cosine positive besides quadrant 1? Answer is quadrant 4. What is the pi over 3 in quadrant 4? It is 5 pi over 3. Those are your two answers, and you got it. Hope that helps you. Watch as much as you need to. Move around on it, whatever. I just hope it helps. Sorry about the no calculator thing, but I think you got that. All right. See you tomorrow when you come in and make triple digits on this test.